Yeah, that's right. Good point. What? Oh, hi! Welcome to the final trig video on cosine law. All right, cosine law. Well, unfortunately, despite the usefulness of sine law, there are certain triangles where the sine law doesn't work, where we don't have a matching side and angle. We don't know B and B, or A and A, or C and C, or E and E, or Q and Q, or S and S. Okay, I'll stop. In those cases, we must use something else called the cosine law. It's written below here. Isn't that exciting? A squared is equal to B squared plus C squared minus 2BC cos A. Or B squared is equal to A squared plus C squared minus 2AC cos B. Or C squared is equal to A squared plus B squared minus 2AB cos C. Wow, that's a lot to say all at once. I just want to show you that we could rewrite this for any triangle no matter what the name of the triangle is. Let's say you're dealing with triangle STR and you wanted to find side T. Okay, well you could rewrite this as T squared equals, well, S squared plus R squared, the other sides, minus 2 times S times R times the cosine of the matching angle T. Okay? Whew, that is a mouthful of a formula. All right, for our first example here, we're going to want to find angle B and angle C and side A. And my printing out on the PDF has resulted in this 51 being obscured, but that's a 51 for side little c. We know side little b is 42, and this angle here is angle A is 39. Okay, so the printing ended up shifting everything over a little bit. Okay, oh, well this is a problem. I don't have a matching A and A, or B and B, or C and C. So I have two options now. First option is that I could panic and run away from this problem forever. The second option is that I could find side A by using the cosine law. Now, let's try that strategy. Okay, so side A can be found using A squared equals B squared plus C squared minus 2BC cos A. Actually, it's just a matter of filling in a really long formula then. That just tells me that A squared is equal to 42 squared plus 51 squared minus 2 times 42 times 51 times the cosine of A, which is 39 degrees. Oh, it's just that. Okay. Well, it's just something long to type in. That's all. So I'll type it all into my calculator right now. 42 squared plus 51 squared minus 2 times 42 times 51 times the cosine of 39. And that gives me that A squared equals 1035.7 yada yada. To find A, I just have to square root both sides. And I'll find that A therefore equals, the square root of that number is 32 point, well, after rounding, we'll say 2 centimeters. There. By the way, it's not plus or minus 32, even though I square rooted both sides of the equation. It's just positive 32 because there's no such thing as a negative side value. Okay? You definitely don't want to meet a negative side value at a party. Okay, so that side A is 32.2 centimeters. Now that I know side A, I can use it in order to solve for angle C or angle B. And I don't have to use cosine law anymore. Now I can use sine law to finish the problem. And so I could set up, for example, sine C over side C equals sine A over side A. So sine C, unknown, over 51 equals sine 39 over A, which is 32.2. Multiplying by 51 on either side gets me that sine C equals, now that whole mess, again, I need a calculator. Type it all in, sine 39 times 51 divided by 32.2 gives me 0.9967, etc. And so angle C is the sine inverse of that number, blah, blah, blah. It's easy to just write blah, blah, blah when you don't have to hand it in for a test. But don't do that at home. Okay, let's see, that gives me 85.4 degrees for angle C. How do you find angle B? I'll leave that for you. We can rewrite cosine law, by the way, if we wanted to find an unknown angle. Right here. Hey, look, this looks like fun. Cosine of A is equal to B squared plus C squared minus A squared, all divided by 2BC. Whew. So if I wanted to find any angle, A in this case, I square the other sides, subtract the square of the matching side, and then divide by 2 times B times C, times 2 times the other two sides. What if I wanted to find angle E? Well, the cos of capital E, I square the other sides, in this case this triangle, that's D squared plus F squared. Then subtract the matching side, so that's E squared. Then divide by 2 times the other two sides, times D times F. And so that gives me that the cos of E, to plug in this mammoth formula, is 32 squared plus 21 squared plus, or minus 41 squared, all that divided by 2 times 32 times 21. Again, we've got one heck of a mess there, but it can all be typed in. And you got to be careful when typing this one in. You might want to partially type it in, like just type in the numerator. If you do that, you get the cos of E. The numerator gives you negative 216 divided by the denominator, 2 times 32 times 21, 1344. Okay. And so angle E is then the cos inverse of negative 216 over 1344. Cos inverse of negative 216 over 1344. 99 degrees. Isn't that a nice round number for angle E up here? Okay, 99 degrees. Okay, that's cosine law. Now, you're going to see problems where I don't tell you what law to use. Let's take a moment to think about that. If no diagram is given, okay, draw one to represent the situation before completing the problem. Okay, that might seem, I don't know, like a waste of time, but doing the drawing lets you know what you're going to expect. Are you dealing with an obtuse triangle, a right triangle, an acute triangle? Are you dealing with an ambiguous case problem or not, etc., etc.? Okay, so here's some tips. And that's all I can give you is tips when you're dealing with this. Check for right angles. That is 90-degree angles. Okay, and if you got a right angle, guess what? You can just use the old school SOHCAHTOA that you know and love. Just use the regular trig ratios. Okay? Check the triangle, though. If you don't have a 90-degree triangle, check the triangle for a side and a matching angle. Like A and A, or B and B, or C and C. That's a much easier law to use is sine law. And you can only use sine law if you have a matching side and angle. Well, and then unfortunately, if none of the above exists, use cosine law. So if you can't find a matching side and angle, that's okay. You still have this final backup called cosine law, which is really a large formula, and it takes a little long to type it in. But, in the end, it's just a formula that you plug in to find a value. It's really not the end of the world. Okay. I wanted to look at some examples, but they seem to have displayed very badly in here. So what I'm going to do here is panic. No, what I'll do is instead quickly redraw this triangle. And you'll just have to live with my rough drawing of it. Okay, I know angle C is 75, angle A is 50, and side B is 38. And I'm wanting to know what is side C. That's this side right here. Well, how can I find it? Well, it'd be nice if I had a right triangle. I don't have that. Second, I want to see, can I use sine law? And you might be ready to say no, because there's no matching side and angle. But in fact, I could use sine law if I just notice that B is here, and B is over here, and I can find this, angle B. To find that angle B, that's just 180 minus the other two angles, 50, 75. So 180 minus 50 minus 75 gives me 55 degrees. Now I happen to know angle B and side B. I'm looking for side C. So I'll set up sine law with the matching side and angle. I'm looking for C. I know sine C. I know B and B. Okay, filling it in, I get C over sine 75 equals 38 for B over sine B, which is sine 55. Multiplying both sides by sine 75, you end up isolating that C is equal to 38 times the sine of 75 divided by the sine of 55, which, typed into your calculator, gives you C equals 44.8 centimeters. Next, find angle B in this triangle. Well, is it a right triangle? Well, maybe, I guess. We don't have enough information, but it doesn't look that way, so it's not a right triangle. Can I use sine law? Nope. I don't have a matching A and A, or B and B, or C and C. Can I use cosine law? No, as it turns out. If you wanted to find angle B, you would need to use cosine law, which tells you cos of B equals A squared plus C squared minus B squared over 2AC. To find angle B, you need to know all three sides, but you don't. Okay, in fact, what you would say in this case is there is insufficient information. There's not enough information. As it turns out for a triangle, if you only have two pieces of information, you do not know enough about that triangle. In all problems, you must know three things about the triangle in order to solve. All right. And a final problem for us to end off the chapter on trigonometry. Here we go. A tower is supported by two guy wires attached to the top of the tower and fixed to the ground opposite sides of the tower, 27 meters apart. What this means is we've got a tower. It's a beautiful tower that I've drawn. And we've got two guy wires. Okay. We've got one guy wire here. And a second guy wire maybe over here. Okay. And we know that the two wires touch the ground 27 meters apart. Okay. One wire is 19.3 meters long and meets the ground at an angle of 53 degrees. And there's the situation. Okay, a few questions for us. A, what is the height of the tower? B, what is the length of the second wire? And C, what angle does the second wire make with the ground? All of these can be answered using the knowledge that you have in trigonometry. And this is the problem I'd like you to try and bring into class to complete now. Thanks for listening. Bye for now.